Well, I've got just summarising briefly and taking you through what you're supposed to have read already before this session, but you might not have done. But it's just thinking about all these different types of concentrated fertiliser. And I'm actually going to start up here with this volcanic rock dust. There it is. If you had a chance, come up and have a look at it. Ground up into partly a dust and partly a grit. And that reminds me I'm supposed to tell you about the law of surface area. So here we've got, to illustrate, it's a block of chalk. Right? So that block has got a surface area of about 10 square centimetres. 10 square inches, let's say. So inch, 2 inch. It's about 10 square inches, its surface area. That means it's only this bit on the outside that can react either with the soil or with microbes or nutrients or the compost. And then what I've got here is calcified seaweed. And this is a bit similar to, this is the process that made the South Downs. And you could call it it's almost like the coral that you get on coral reefs. So this is the structure that a little wormy organism has made on the sea surface, and it's deposited calcium basically. And the good thing about it is it's got magnesium in it as well, which we want, so that's better than just ordinary chalk. Calcium carbonate, this has got magnesium carbonate in as well. But now it's in little lumps. This is the form it comes in, and that will have a surface area about 1,000 times greater than this big lump of rock. So, and then it's ground right down to a fine powder. That's calcified seaweed again, but ground up into a fine powder. Now that's going to have about 10,000 times the surface area of the original rock. So that's how quickly those nutrients get into the soil. I can throw bits of chalk onto my soil and wait for 5 or 10 years, and the ice and the frost will break it down eventually. But if I want something to act initially, immediately, or to be more efficiently broken down and available in the soil straight away, then I use a finer broken down bit. And it'd be the same if you were spreading manure. If you leave it in great big lumps, it's not going to get to the middle of the lump yet, but if you chop it up and it's finer, smaller particles, it's going to be more effective. So that's thinking about what we were saying about soil. Turn your soil, break it up into smaller lumps, and then if you introduce your bulky organic matter and your concentrates and distribute it thoroughly, but it's all about the surface areas of the different materials being able to react with each other. Yeah? So that was reminding me about that. But the volcanic rock dust, that's got about 50 trace elements and minerals in it, and really it's proto-soil. And I've taken on several allotments which they were the fertility was completely used up. Nobody had put any manure in for decades, and the practice was that they just ended up using chemicals and forgot about using manure and didn't have access to more of the organic stuff. This for renewing a soil, for giving it a whole new lease of life. If you could put a big bag, 25 kilo bag of this onto an allotment size, 1/8 of an acre, you'd have 3 to 5 years where that soil is going to be generally much more fertile as this stuff breaks down, weathers and gets brought into the system by action of microbes. So volcanic rock dust, it's also called basalt flour, just ground up basalt. And actually even granite, you can grind it and it will release some of the same nutrients. And that's a bit like we were describing the soil processes, the act of glaciation, the extreme pressures of glaciers moving up and down over the landscape, just grinding rock down to a tiny particle size, which is clay formation. So volcanic rock dust, worth using to renew old soils. And I'll work my way along. I've got a sample of hoof and horn. That's a darker green sample. This is one which has been made into pellets, and generally if you're in market gardening or farming, you want pellets which you can then scatter in your distribution machine. Whereas this is out of a bag and more powdery, smaller amounts. And moving on to things like hoof and horn. That's hoof and horn. The bloodfish and bone, I've got various samples of that as well. This stuff in the container, darker material, again pelleted, and that is this Grow Safe, which is a good organic formulation. and worth spending extra money on. The chicken manure is an everyday, this is available everywhere. It's going to come from industrial-sized chicken factories, so it's got a downside on that. But it shouldn't be too messed up with chemicals, so it's an acceptable alternative to blood, fish and bone, especially if the blood, fish and bone's got chemicals in. And then, that was the side swipe at this stuff, which is just pigeon droppings, concentrated, so that is essentially the same as the chicken manure. And like I said, needs grinding up and spreading and diluting before it gets onto plants, otherwise it will singe and hurt them. And this alternative to bone meal, the rock phosphate, we actually went to a company in Chesterfield and bought a ton of that, a ton bag, and they import it from Tunisia. And what they do is they then soak it in sulfuric acid, which produces a liquid soluble form of the phosphate that can then be sprayed and added into other mixtures. But it will make it more kind of effective. But yeah, that's quite a lot of action to go to. This rock phosphate here, this is in little lumps, and that has actually been mixed with calcium, with the calcified seaweed or chalk. And that's because the more phosphate you put in, the more lime is required. So this is, again, a balanced, rather than just dosing the soil with phosphate and it makes it more acid, this is anticipating that and putting lime in at the same time so that you don't get a disruption to the soil. And that would be generally true of all these really strong fertilisers, blood, fish and bone and the hoof and horn. If you use too much, you will acidify your soil. And ground up bones, that's bone meal. Various old stories. When you're planting a grapevine, you're supposed to bury a dead dog or sheep under it.
You got one of yours?
Actually, I did have a mate who buried the placenta of his first child under a gooseberry bush. So there is all different options like that. That's,
why did you suddenly get nervous then when you were talking
yeah,
about
I'm not talking about this. Not yet.
well,
Wait another few years. But yeah, bone meal has been sterilised, and I was lucky enough to live through and survive the foot and mouth Armageddon that we had in 2001, when the whole countryside was closed down and none of the farmers could operate at all, and crops were rotting in the field and they were burning all their cattle. I did actually ask the state vet, would we have been able to compost all those animals, and would that have been safe in those terms? And he said yes. So burning them was just for show, and to show everyone else abroad that we're dealing with it. But actually, from a health and safety point of view, we could have put all that fertility back onto the land. But yeah, I'm just mentioning that in terms of bone meal, that's sterilised, and it is one where if this is it CJD, is that the right? If that is a long-term impact and too many burgers are going to give you it in 50 years' time, that was just another way of reducing. But yeah, bone meal was then banned from garden use. I think it's back in now, and you can get formulations and mixtures of it. But for a while, that was illegal. Hey, therefore more fun to use. Yeah.
The phosphate and lime, what was that?
That's just a proprietary mixture, rock phosphate with lime added in.
Can you remember when you were using basic slag?
Well, that's another one. As well as forms of lime, this is kiln linings, or basic slag.
Yeah.
And you'd get a brick lime kiln, which you'd then basically plaster with the lime-based product, which would reflect the heat. And then, the history around here was they closed the kilns down, and it took about 6 weeks for the kilns to cool down enough to actually get into. And again, my mate, the caretaker, he got a job every summer, and he'd be sent in to the extreme heat when it was just cooling down enough to get into, and they'd have to knock out the basic slag, the lime, and that would be spread on fields. But the danger with that being contaminated with other chemicals, who knows what. I've used it once and I didn't get a good result. I wouldn't use it again. But that reminds me about what I've mentioned in here, which is plaster. So this is from going around skips. And as soon as plasterers have opened up a bag of plaster, it's drawing in moisture. So if they keep it for a week or two, it doesn't make up the same way. So they're going to chuck it on a skip. Now that's calcium sulfate. So it's different from what I've shown you, and it's going to have a much more aggressive effect on the soil, a much more of a chemical reaction. And so it's useful for breaking open a heavy clay, calcium sulfate plaster, but I'd want to wait 6 months before I put a crop in afterwards. So in the early initial stages, if you've got it available, you could use some of it up, but don't rely on it long term. Not as nice as these other forms of calcium. I'm going to get on to seaweed in a minute, but yeah, first I'm going to show you some other forms of long-term slow-release fertiliser, especially when we're thinking about fruit, whether it's the soft fruit you'll be getting next week, or your tree planting. Driving around last year, there was loads of roadkill. There was one road up by Strines, and only every 10 or 20 foot or so there was another baby wabbit actually. But this was pheasants, so I've got every feather on the pheasant was different. I plucked it. And some of that has been buried in the soil that fruit are going to be planted onto. And I learnt this trick from, again, skips, getting feather cushions, feather pillows. And I didn't have to get involved in the grot. But yeah, feathers, they'll break down quite quickly, and these are made of keratin or chitin. And that's the same as your hair and your nails. So we've actually got our own sources of these materials, but maybe not enough to fertilise a tree. But yeah, feathers, a nice product if you can get them out of an old mattress or old. So yeah, hair is basically the same, and these are all going to produce, especially nitrogen, gradual, long-term, slow release. So the feathers will take 6 to 12 months minimum to break down. Hair, that could take 3 to 5 years to break down in the soil. And also I've got wool shoddy, which is get an old carpet that's definitely made of wool and not half plastic or not synthetic, and just leave it in the sun, outdoors, for 6 to 12 months. And then it breaks down into, again, if these are in small particles, small little bits, then they're going to mix into the soil and be available quicker. But that's just old carpet, old bedding, and I did actually go and collect from hairdressers and washed material. But hair, these are all long-term, slow-release fertiliser, especially good for using with fruit trees. So if you get any of those kind of materials from now on, rather than thinking they're a waste, now they're valuable. And that is trying to interpret the whole world in terms of we're after the organic materials which will break down, and trying to avoid the synthetics which are going to just be a waste problem in the future. So that's a bit of detail on the concentrates. This one, horrible, dried blood, where's that? That one there. These are little platelets, because blood is flat platelets. And when you mix this with soil, it doesn't really mix in properly. So you mix a bit of soil with that first, and then it'll spread. And I don't tend to use that much, but if you were growing salad crops intensively, like lots of lettuces all the time, this is high in nitrogen, and the connection is between nitrogen and leaf growth. So that's why the farmers stuck it on the cabbages. I wouldn't like to use that myself, definitely not on its own, but that's the connection. Nitrogen produces leaf growth, whereas things that have got more phosphate in them are good for root growth, and potash is good for root growth, and phosphates for, like I say, flavour and appearance. So we're up to do, and yeah, let's have a little breakdown on the seaweed, which is the next leaflet on page 23. I've not brought a sample of actual stringy seaweed from Brighton Beach, but I do collect that up now and again. Most of the seashore seaweed will be fine to use, but if you went to the west coast from here, you'd end up with radioactive seaweed, and if you went to the northeast coast from here, your seaweed would all be covered in coal dust from the coal minings at the shoreline. So there are places you might want to avoid collecting seaweed, but you can just go and collect any seaweed off the shore. If you're going to cart it around, dry it before you cart it around, because it can get very smelly after a couple of days, and it's about 10 times lighter. But yeah, that's this hydrological cycle again. All the soluble nutrients that we talked about, which were once on the Peak District in the soil, were washed away 1,000 years ago and are now available in the soil. So that's things like iodine, and I explained that that's crucial for your thyroid system. But yeah, this gives not that much of a boost to growth. It's got a little bit of nitrogen, but it's bringing in all the trace elements and especially the ones that will be washed away from high ground and most soils, will be deficient in seaweed, and I'd actually put it directly into the soil. But I could also, let's go through this leaflet. So the best use of it would be to add seaweed to compost. And then you've got 6 months in the compost where the seaweed is bonding onto other molecules in the compost, and then the trace elements that are in that will be held in the humus molecules until the plants want them and need them. So it won't just get washed away again. If you just spread it in the soil, some of that material is going to get washed away. But it will bond your soil together, and like a gel, it forms a gel, and that can actually is good for soil generally. Or if I'm growing a crop, and I mentioned earlier that with some of these expensive materials that I have to buy in, I might wait until I know I'm going to get a crop before I commit to actually putting extra fertility in. So I could get the plants going up to halfway without too much extra nutrients, and then if I've got a successful crop that's got that far, then I might add more nutrients in, and either as a crop fertiliser, just distributing them around in the soil underneath and hoeing them in and watering them in, or make a liquid feed, which in the case of seaweed it would only take a week or two, for that to dissolve and ferment up, and then the nutrients are available directly to the plant's roots as soon as you put them in. What I'm describing is through the life of a plant. If we can get the seaweed into the compost, that's best. You can spread it just into the soil, but that's a bit lavish because some of it's going to get washed away. And then if you wait until maybe your crop is flowering before it produces its fruits, and then you fertilise then. So you've made sure you've actually got a potential crop, and then you commit to a bit more fertiliser and fertilise the crop or liquid feed. Or, once plants are growing up to their full size, like with potatoes, when they're just 6 inches tall, there's not much leaf. But a month later, when they're 2 or 3 foot tall, and you've got loads of leaf, well, that's when you do foliar feeding, foliar spraying, and the nutrients from the seaweed liquid would get digested through the leaf. So it would be a way for plants to pick up extra nutrients that they hadn't found in the soil. So if you had a plant that was not looking well for some reason, yellowing or something, that's one suggestion, to actually spray seaweed directly onto the leaves, and that can counteract and bring them round and keep them going. And the last usage there, like I say, with the leaf mould, if I can make my own potting compost and my own seed compost, then I'm saving a lot of money and I get a regular performance in the material. And I wouldn't want to put the fertilisers into the seed or cuttings compost. But if I'm potting on, say, tomatoes or peppers into a big bucket, then I put soil, leaf mould, compost, maybe a bit of manure, and then seaweed and bloodfish and bone, and maybe some of the hoof and horn, to concentrate enough fertility into that small bucket that my great big tomato plant can actually produce a decent amount of fruit through its life. So that's the different ways, and what I've written down here for seaweed, to some extent applies to all the other fertilisers. If you can get them in compost, that's best. With things like the long-term slow-release fertilisers, get them in the soil. But if not, you can create a liquid feed and still catch up later on and get your total fertility budget to add up to enough eventually. So various ways of going about that. And you've all got your samples of leaf mould. And like I said, that's nice old stuff. So the leaf mould, just 1 or 2 points, and I'll talk you through, but the bits in red are maybe the most useful bits. So the recommendation through the media is that you get your black bin bags and fill them full of leaves, but it doesn't bloody work. So if you've only got a small amount of leaves, if they're wet, they'll get preserved because their moisture will preserve them. And if they're dry, they'll get preserved and won't change at all, and you'll open your bag in a year's time and they won't have changed into leaf mould. So leaf mould, let's get it clear, is this process partly the heating up when we've got a large heap, but crucially this action of actinomycetes, the slime mould, which is what's breaking down the cellulose. So after they've heated up, they still look like leaves. But 6 months after that, when the slime mould, which is this hybrid between a fungus and an algae, has penetrated through the heap, that's the bit that breaks down the carbon, the cellulose, in the leaf structure, and then it rubs down to this lovely fine consistency where you can't see any of the pattern of the original leaves. So don't use bin bags, get as much as you can, don't use young ones, and yeah, keeping leaves separate from the compost and other heaps like manure, rather than sticking a load of leaves into the manure, keep them separate if you can and have them as a separate process, and that's so you can produce a low fertility medium. So this is about fertility, but in this case for seeds, the classic example is people hear about, I might have mentioned this before, I'll say it again, people hear about potting compost and they think garden compost is what you put into potting compost, and they put their seeds into garden compost. Well, the garden compost has got all the microbes that digest vegetation and organic matter, and basically their seeds are eaten before they even germinate. And if they do germinate, they're strangled by too much fertility because the garden compost is too strong. So that's the rationale for using leaf mould as a low fertility base for sowing seeds, which can survive on their own with no help, just water for a month. Or cuttings where if you had high fertility around them when they're just forming a little root, again it'll kill the cuttings. So just get that clear in the mind, and that's why I call a potting compost, I don't call it a potting compost, I call it a growing medium, to make sure it's separated off from the composting process, which is the big garden scale composting. And yeah, to answer Ash's question from earlier on, so in the case of leaf mould, I'll stack it in layers, flat horizontal layers, and the first time I turn it, which might be a couple of weeks or a month after I've stacked it, I'll have to turn it with a fork because it won't chop through. And the idea is basically to invert the top goes to the bottom and the bottom goes to the top of the new heap. And later on, 6 months later, once it's breaking down and becoming leaf mould, then I can chop through with a spade and slice it through and just lay each layer down so that vertical layers become horizontal layers. And that is applicable to composting as well. And that's the main thing I've got to say about that. And yeah, later on, when I've made a batch of leaf mould and I want to process it and prepare it for potting compost, I'll riddle it, and I've got various different sizes. I've got 0.5 centimetre and 1 inch mesh that I can pass this leaf mould through, and what doesn't go through the mesh will be little sticks and little stones. I keep them separate and they produce grit, which is great if I want to make cuttings. Larger particles, stones, easier for the young cuttings to root through. Again, I'll show you that in section 7 on propagation. But yeah, that gives you a little introduction to the composting process. And this 2-pager here, that was done for the community compost and presented as a workshop to them several times. So it's got all the answers, and I've kind of explained this, but I'll very quickly summarise again. The first bit is I've got bulky inputs like manure, crop waste, veg waste, and then I've got little bits of other things like I might have a bit of straw, a bit of card, might go and cut a bit of comfrey or nettles and add that to the compost, and then what I've called additives, which are basically these concentrates to add fertility, and then inoculants, which are only small amounts of. And I've put loam as the first one, topsoil, because that's got the microbes that are actually going to breed in the compost heap and do my composting for me. If I don't put any soil in at all, it'll be harder to get the right microbes in there. And if I actually recycle a bit of mature compost, well, that's going to have compost worms and their eggs in it, and they'll sit around until they're needed, and that will give a population of worms from the start. And those biodynamic preparations, again, as an inoculant, it's a very minor amount going in, but it can have quite an impact and an influence on how well the process goes and what comes out the other end. I've shown you the sites which are open and mentioned about, rather than composting on concrete, which is what the authorities tell you to do, you're much better off composting on soil. And then worms can get out from below, and microbes, and also drainage. It'll drain down into the soil effectively. The stacking is basically in layers, and the coverings I've shown you, and the turning. And so on the second side, let's summarise again. First, in compost heap, when it's heating up, for up to 3 months, you're talking about decomposition. So you put whole vegetable in, and it rots down to become mush. That's the first half of composting. And this second half, recomposition, that's the real heart of proper composting. That's when it's built back up into a stable humus molecules, which is your real compost. So after about 3 months, your mushy stuff, it wouldn't hurt the soil too much to put it in, but like I say, into rough soil in the early stages. But waiting another 3 to 6 to 9 months for it to get built back up. And to summarise, that is, microorganisms break the stuff down, and macroorganisms, like the compost worm, build it back up and recompose it into proper compost. So it's 2 halves to the process. And just summarising, we've talked about the balance of carbon and nitrogen, and generally that means you might have to bring extra materials in to supplement what you've got from your own supply. So if you've got veg waste, food waste, bring in manure or straw or something to soak up the liquid in it and balance out the excess nutrients in it, especially if you're a meat eater. And then down here, phages or phages. Do you know this one, Asha?
Viruses that prey on bacteria.
So we're right down at the microscopic level, and we think of bacteria as tiny, but there are these viruses that eat bacteria that are even smaller than them, and they actually genetically mutate quicker than bacteria. So this is one of the hopeful things about, what do they call it, MRSA, is it?
Yeah, I think
The
so.
multiple resistant, yeah.
Bits of the DNA of the virus can insert into the bacteria, so the bacteria
So they'll get,
produce bits of it.
so they're feeding off each other almost.
Yeah.
To some
And
degree.
then you can
Yeah.
swap. They can also swap
Yeah.
bits of DNA from another bacteria into the first bacteria, can't they? So that's how
Amazing.
it could.
But they can out-evolve bacteria, basically. So here's the proposition. We're getting this resistance problem with antibiotics, which we've had for quite a long time, and it's getting very, very, very serious. And I saw this program about Russia, and what they were doing in Russia, so just to preface this, rather than having a golden bullet where everyone can take antibiotics and everyone will be okay across the whole wide world, that is the solution that we've tried and is now failing. The proposition with phages is, if you collect diseased material, and in the programme I saw it was sewage waste from a hospital. They were collecting the sewage waste and they were putting it in copper vats and cooking it up for a couple of weeks, maybe, quite a long time, at a low but meaningful temperature. And at the end of that process, all the bacteria had been consumed and they only had phages or phages left. And then they took that material, which they'd taken from the sewers, and they sprayed it around the hospital ward. Now, because they've taken it from the specific place where the dirt or bacteria was coming from, and they've actually genetically engineered phages for that specific spectrum of bacteria, it works. Now, if you took that sample and took it to another hospital, it wouldn't work, because you'd have different bacteria that hadn't been eaten by the phages. But yeah, that is, again, illustrating organics, that to make that an effective system in hospitals, you'd have to have a phage department. Guys in every hospital cooking up a specific menu, a specific recipe for that hospital or that situation or that individual patient maybe. So it's a different from having one multinational company in Switzerland that makes it for the whole of the world. But as far as I know, that works. And that's one of the things that will come out at the end if you do good composting. So that will also have these phages in it, and that's not especially for your own human health. But it's that balancing process that at the end of good composting, you'll get something really beneficial out of it. Also, I've mentioned just that difference between the seasons, that in spring and the autumn, temperatures are balanced, and that's great for composting. And that fits in, especially with clearing up in the autumn, making compost in the autumn to tidy up. But it's a good time for composting when all the right bacteria are floating around in the atmosphere and will land on your heap. And one more little bit, I've mentioned about the biodynamics. And yeah, last bit to get you interested in composting, there's always been this alchemist's dream about turning base metals into gold. And so as I was shifting this shit around and veg waste for 15 years, I thought, at the end of this I'm going to get some beautiful fruits and lovely vegetables, and it's got to be worth it. So that's another thought, that yeah, it is alchemy, that you're taking horrible, smelly, gacky stuff, but at the other end of it, if you can produce lovely food, then it's turning into gold. So, and your diagrams, that's illustrating what was illustrated in your pictures, a bit more detail, basically in layers, structuring it and consolidating each flat layer, and that is just summarising what's in the leaflet anyway, adding in your activators and your compost cover and your covers on top, and just another presentation of the turning, where we can think of it as top to the bottom, bottom to the top, but also inside out and outside in. So as you're turning your heaps, if you keep that in mind, and basically, like cooking, you're just trying to get all that material thoroughly cooked through. So if it's been on the bottom, it'll be cold, put that to the top. If it's been on the outside, it'll be cold, get that into the middle. And what else have we got? And worm compost, take that away. You can convert regular bins, but there are some really good systems, if you can afford them, to actually buy with taps and the right kind of tops to. But you need to create this structure with bedding material in the bottom and a kind of nesting area at that point, and then feeding on the top above that. But we could all, anybody on any scale, and even indoors, there's a lovely lady who does worm composting, and she's got her worm composters in her kitchen, so it can be compatible that way. And I've mentioned most of these materials. You've just got a few samples up here, and these about 20 from that compost competition. Most of these other materials up the end, like these are perlite and vermiculite. They're super expanded aluminium silicate rocks, but they're very fluffy and light, and therefore they hold moisture and or air in the soil. They're great for the potting composts, but again, I'll come back to that in session 7. There's a bit of coconut fibre. That's coming as a block. When you wet it, it expands to about 10 or 20 times the size. Some of that's been expanded there. And that's one of these many byproducts of industry. So that's part of the theme this evening. If you're going for a product, you'll be buying something that, that's been carted halfway across the world, but otherwise it might have just been dumped. And I mentioned halfway through that the nicest mulch I ever got hold of was cocoa shell, cocoa as in chocolate. And when you opened the bag, it smelled like chocolate and you wanted to eat it. It was gorgeous, but that made a rather classy mulch. But yeah, whenever you're buying stuff in, you're dependent on these bigger industries like the poultry industry for the chicken manure, and we've all got our ethical decisions to make. So the more that you can source locally and stop us flushing all our cities' waste down the sewers, and rob things off skips and go to see local farmers who can supply local manure, the more that you can get from local sources, the less you'll have to buy in, and the less your growing will cost you in the long term. And like I say, that message about diversity, the more things you can get hold of and bring into your system, the better your flavour of your veg is going to be. Okay, overrun just by a quarter of an hour. So that's great for this evening. We're doing sites next week. Now, if anybody's done one already or can get one done by next week, can you do a site plan or design or just a drawing of where you're growing? And you might actually, you could bring some pictures in, but we'll have a different session and use your material, your sites, as part of the content for next week's session, sites and designs. Okay.
Thank you.
Thank you.
Last call out for fruit stock. I'll bring some of these fruits along next week. Hopefully all of them.
You know the
Still some bits of squash, yeah.
Sorry, you know the chicken?
Yeah.
If you get it like that.
Well, that was chicken meal. That's pigeon meal. Pigeon dropping.
Okay.
And that's quite vegetarian.
Okay. So if I was to get chicken chickens and someone gets it from a local farmer, let's say,
Yeah.
do I need to chop it up or mush it up or
So,
soak it?
if you're doing a bit of composting,
Yep.
break it up and spread it into the compost to dilute it and to consolidate and make those nutrients long-term available. And if you're going to use it direct, use it only on mature plants and break it up, or maybe put it in water so it's distributed in the soil more. And the only danger would be certain plants, if you put too much on it at one go, it might actually shock them more, burn them. What's your local chicken memory?
It's Bournemouth Farm, I live, that's where I live.
But yeah, get some in and mostly dilute it, mix it with other things, compost it.
Yeah, okay.
But yeah, useful.
Yeah, thank you.
Cool.
Did I understand you right that
We take a bag of leaf mould.
okra
Yeah.
Ochre?
Ochre.
Yeah.
To put that in just in the leaf mould.
That's a good question. Just here's one. Renata's asking about, could she put her ochre just into leaf mould? Not enough nutrients long term. It would grow, so if you've got nothing else, you can. But if you mix this 50-50 with soil, any soil from the garden, or even multi-purpose compost, 50-50, that will be better for the ochres.
Okay.
And another option, if you save this for next week, I'd say this bag is enough for 1 or 2 of the soft roots. So you dig that into leaf mould into the soil, and then the soft roots, 1 or 2 of them will do better. But
Okay. So half and half the normal soil, garden soil. Okay, thanks.
careful.